Hi, I'm Brandon Lee. This is Math Free to You, and today we're going to be talking about systems of equations. A system of equations is a group of two or more equations. For simplicity, we are going to be looking at systems composed of two linear equations. Let's begin with the system negative x plus y equals 4 and 3x plus 3y equals 6. Now the solution to this system is x equals negative 1 and y equals 3. We can check that this is the solution by plugging those x and y values into both equations. Negative 1 times negative 1 is positive 1, plus 3 equals 4. Negative 3 plus 9 does equal 6. Now this is the only solution to this system, so we call these equations linearly independent. Let's look at another system of equations. Negative x plus y equals 4, and 5x minus 5y equals negative 20. A solution to this system is x equals 0, y equals 4. As we can see, the ordered pair 0, 4 satisfies both equations. 0 plus 4 does equal 4, and 0 minus 20 does equal negative 20. Another solution is x equals 1, y equals 5. We can verify that this is a solution as well. Negative 1 plus 5 does equal 4. 5 minus 25 does equal negative 20. In fact, there are infinitely many solutions to this system. We say that the equations are linearly dependent. Now we'll look at one last system. Negative x plus y equals 4, and negative 3x plus 3y equals 6. There are no solutions to this system. That is, there is no ordered pair, xy, that satisfies both equations. We say that the equations are inconsistent. Now how do we find the solutions to these systems of equations? One method is to graph the equations. Let's look at our first system again. Negative x plus y equals 4, and 3x plus 3y equals 6. We'll start by putting the equation into slope-intercept form to make them easier to graph. Adding x to both sides of our first equation gives us y equals x plus 4. Subtracting 3x from both sides of our second equation gives us 3y equals negative 3x plus 6. Dividing by 3 on both sides gives us y equals negative x plus 2. We know that the graph of the line y equals x plus 4 is the collection of all the ordered pairs xy that are solutions to negative x plus y equals 4. And we know that the solutions to 3x plus 3y equals 6 make up the line y equals negative x plus 2. So any point where the lines intersect is a solution to both equations. Graphing confirms that the unique solution to the system is negative 1, 3, and that the system is linearly independent. Why don't we try confirming the solution to our second system? Negative x plus y equals 4, and 5x minus 5y equals negative 20. We saw in the last problem that the slope-intercept form of the first equation is y equals x plus 4. Subtracting 5x from both sides of our second equation, we get negative 5y equals negative 5x minus 20. Dividing both sides by negative 5, our equation becomes y equals x plus 4, which is the same slope-intercept form as our first equation. The solutions to both of these equations form the same line, which confirms that there are infinitely many solutions to this system, all of the form x equals x and y equals x plus 4. This is what a linearly dependent system looks like. Now for the last system. Negative x plus y equals 4 and negative 3x plus 3y equals 6. Again, we already know the slope-intercept form of the first equation is y equals x plus 4. Adding 3x to both sides of our second equation, we see that 3y equals 3x plus 6. Dividing both sides by 3, we get y equals x plus 2. Notice how these lines have the same slope, but a different y-intercept. Graphing the solutions to both of these equations, we can see that the lines are parallel, so they never intersect. Therefore, there are no solutions to this system. The equations are inconsistent. Well, that's all for this video. Look forward to future videos on other methods of solving systems of equations and all other things math related. Thanks for learning with us.